Alright, so today we're going to be talking about the diesel engine cycle. So Rudolf Diesel was the inventor of the first diesel cycle, well, diesel engine in the 1890s. The first successful diesel engine test was on February 17, 1897. Which had an efficiency of 26.2, which is about 16.2% greater than the steam engine at that time. And the definition of a diesel engine is any internal combustion engine in which air is compressed sufficiently at higher temperatures to ignite diesel fuel, inject into the cylinder where combustion and expansion activate as a big piston. So this is the basic, diesel engine. So the main thing is that you have your glow plug. Diesel fuel doesn't have a high, flash rate like gasoline, so it's got to be heated before it, ignites. There's also a turbine or a turbo on this other side. That's what's going to give your, higher combustion process so you make more horsepower and torque. Everything else is the same as a normal gasoline engine. So the basic process, you're going to have, your compression from 1 to 2, your combustion from 2 to 3, then your expansion from 3 to 4, and heat rejection, which is your exhaust from 4 to 1. Some basic equations are, your heat transfer, your efficiency, your cutoff ratio, and then your specific heat ratio and compression ratio. So the relationship from top dead center to bottom dead center, you have your isentropic compression from 1 to 2, your constant heat pressure addition from 2 to 3, isentropic expansion from 3 to 4, and then your heat rejection, your exhaust from 4 to 1. So the 4-stroke, it takes 4 strokes to complete the entire cycle. You have, 1 stroke is your intake, stroke 2 is your compression, 3 is your combustion stroke, and 4 is your exhaust. That's a basic, diagram of it. Then you got your 2-stroke engines. Here you have 2 strokes per cycle, which this combines, your intake and your compression stroke into 1, and then your downstroke, which is your combustion and exhaust stroke, into 1 as well. This creates, a different power band, but is also a little bit more efficient on the engine itself. Creates more power. So your pros and cons. For the 4-stroke, for your pros, you have a high level of torque. You're making low RPM. You have 4 strokes per. You're making a little bit more power at that low RPM. You're more fuel efficient. It's less air pollution due to not having the mixed fuel. There's mixed fuel in 2-stroke engines and can withstand a lot of wear over time. Your cons is heavy. It's more expensive for repairs. You got all kinds of moving parts around because it's 4 strokes, and then it's less powerful than a 2-stroke engine. So your pros for a 2-stroke engine is it weighs a lot less. It's a simple engine design because you don't have all those moving parts. Only 2 strokes going up and down. Creates a lot less friction. There's also oil that's inside the fuel that's going to lubricate it, so you don't need an actual lubrication in your oil cylinder or your engine cylinder. Then it's got a high power to weight ratio. It's a lot smaller. It's got to be a lot less, weight there. Your cons is consumes a lot more fuel. It's higher amount of vibration and noise. It's very clanky. Shorter lifespan. It's got to be serviced a lot more. It's like a couple hundred hours, and you got to service it. Narrow power band. So that means you have to get way up into your RPMs for you to see that same power that you do in your 4-stroke engines. And it's a lot more pollution into the air with these 2-stroke engines. So for our conclusions, you have, for your real diesel cycle engine, it creates a lot of compression ratio than your, gasoline cycle as your auto cycle. And the no isobaric heat addition, that is, your fuel has to be heated before, it can combust. That's where that glow plug has to be heated into that fuel. Gasoline has just got a high spark ratio, so it's able to ignite real quick. Ideal diesel cycle overestimates the network and power of the engine. That means you're making a lot more power than your regular you know, gasoline engines. And then the diesel cycle is in a lot of 18-wheelers and large ships, and now we're seeing them into, you know, smaller cars and trucks that they're noticing that you can get a lot more efficiency out of these things. Some of them are a lot cleaner, and now what the EPA is doing, you gotta clean all these things, so it's a lot more, you know, money for them. There's my references, that's about it.